quick words about myself. So I'm Vitalii. I'm the founder and CEO at Dynamiq. I've been doing data science, machine learning for the past 10 years. I had a lot of experience building internal in-house ML platforms at a variety of companies. Probably spent past 5 years in this space, and started Dynamiq about a year ago. And if you want to connect on LinkedIn, feel free to scan the QR code. Happy to chat if you have any specific questions. Also, check out our open source library on GitHub that you can also start using for free. It's under Apache 2 license. So jumping straight into the RAG, let's chat about what's actually RAG is. So RAG stands for Retrieval Augmented Generation, and it's nothing more, as I like to say, as Googling mid-conversation. So it allows large language models and a variety of LLM-based applications to retrieve some information from a variety of data sources and integrate it into the prompt. So it can improve the quality of the answers. It can reduce the hallucinations. You can make sure that you've grounded these LLM answers with factual information that may be specific to your company or to your specific use case. And then also it might be something that allows these LLMs to actually have access to real-time information as well. In some way or another, enabling web search in some of the LLM-based applications like ChatGPT, it's also something that can be called RAG. So this is, in a nutshell, what RAG stands for. So one of the major components in RAG applications, or major steps that you need to take to kind of build RAG applications, to start with a query that comes in. This query is converted to an embedding model, embedding representation, and then we perform the vector search, retrieve the relevant information based on the embedding from the vector DB. We get that retrieved context, these retrieved chunks of documents, and then we can apply a re-ranking. So reshuffle the results that we've received based on additional requirements. Maybe we want to put more weight towards more recent documents, or we want to maybe employ another LLM to only keep very, very relevant chunks. And then we plug it into a prompt. So inject these documents into a prompt, and the LLM will generate the final response. So this part over here, like everything from the embedding, retrieval from the vector DB to ranking, is called the retrieval part in RAG. And then the generative part is something that just leverages the LLM to combine and produce the final results. Core component for RAG applications is obviously the vector database. Similarly to traditional databases like MySQL, vector databases allow you to kind of store, search relevant documents, but the only difference is that these documents are stored in the vector form, in the form of embeddings. So in order to ingest the files or data or text into the vector DB, you first need to vectorize it, convert it to a vector representation, and then you can perform the search. So there's quite a few major players in this space. Folks like Viviet, Quadrant, Pinecone, Chroma, Milvus are probably one of the major players out there, in addition to cloud-based providers like Pinecone that take care of all the necessary things when it comes to vector search. Before these databases existed, we used to perform very kind of basic vector search using NumPy. You can essentially build your own vector database using just NumPy, because it's just a massive array of documents over which you can perform the vector search using, let's say, metrics like assigned similarity or something like that. After that, the more advanced engines came in, like FICE and Annoy from folks like Spotify, that were the first engines to provide more or less end-to-end experience for the vector search. But then folks like Viviet and Quadrant and others provide functionality similar to what RDBMS systems do for traditional databases. So you don't need to care about how to re-index documents and do all the other more complex things. So you just insert documents, and then the VectorDB performs all the magic behind the scenes. When it comes to embeddings, again, it's not a new thing. Like vector embeddings or text embeddings have been there since probably Word2Vec and similar-ish publications, which is probably more than 10, 12 years old now. And the main thing is that we take some text, we run it through a deep learning model that converts that textual representation into a vector that we can use to perform a variety of operations like similarity search. So this model over here, the deep learning model, basically tries to capture semantic meaning of that text. So similar chunks of text are located in kind of near distance between each other. So we can perform all the famous things that have been out there when, we can say, a king plus woman equals a queen or something like that. So these types of transformations on top of vectors. So if we take like a vector that represents a word king, and then we add to it a vector that represents woman, then it should produce us ideally the vector that represents a queen. So that's kind of the primary set of documents that these embeddings are the primary set of documents that our vector databases operate with. Again, something that we can apply after we've done the retrieval part from the vector DB is the re-ranking. So if we want to improve the quality of the results that we've achieved, we can apply several techniques to actually do the re-ranking. As I already mentioned, one of the ways to kind of do the re-ranking might be time-weighted re-ranking. So if our documents stored in the vector DB have some meta information that represents date of creation of these documents, then we can essentially re-rank these documents in a way that newer ones are ranked higher, and then the ones that are older ranked lower. Because when we just perform the similarity search, it will find documents based on the semantic meaning, but it will not rank them in any way based on the recency. So you might have a very relevant document, but based on the semantics, that is quite old, and maybe it's not relevant in our context. So that's where we can apply something like time-weighted re-ranking. And another typical use case to use another LLM, probably more advanced LLM like reasoning LLMs, to do the re-ranking step as well. So you can simply take the retrieved documents from a vector DB based on the similarity search, based on our vector search, and feed them into an LLM and ask it, hey, this is the original query. This is the set of documents that the vector database have retrieved. Please rank them according to the relevancy. And the LLM will try to figure out which documents should go first, which go next. And then we, again, take these re-ranked documents, maybe a subset of these re-ranked documents, and then feed them into another LLM call that will produce the answer. Another major thing that is kind of shaking the industry right now is agentic RAG. Instead of more classic predefined RAG workflows where we define the way documents are retrieved, we can actually provide the agent the capability to query the vector database, and the agent, AI agent, will define when and how it needs to query the vector database and how many times it needs to query that. So this is something that allows us to build more advanced and more autonomous workflows, and we'll show today in the demo how similar workflows can be built using Dynamiq. But yeah, that's probably one of the state-of-the-art approaches that a lot of folks are using to build RAG applications. So now we'll jump into a quick demo where I'll show how to build several of these applications, RAG applications, using Dynamiq platform. Okay, so give it a couple minutes to load. Cool. So now we're inside Dynamiq. I hope everyone can see this. There's a couple of different tabs here. So we have the low-code builder, we have the deployment tab, we have the connections tab where we store all our API keys, all the prompts, the fine-tuning, the knowledge base capabilities, evaluations. So quite a lot to comprehend, but we'll start with connections. So I already pre-created some of the connections to my Google Drive and to the Pinecone vector database that we'll use as our primary vector DB for this webinar. It's already there. I guess we can start first with creating a knowledge base. So in our today's demo, I want to create an HR knowledge base. So we'll go ahead and hit create. I'll say this is the HR knowledge. We can define the way we want to split our incoming documents, which kind of strategy to use, split by sentence or by other attributes. It might increase the length of these chunks to 20 sentences and add some overlap. We'll probably stick today with OpenAI embeddings, but you can choose the ones you prefer, embeddings from Hugging Face or Mistral or Cohere or other providers, and choose the models. And then the same for the vector store. You can choose which vector store do you want to use. Today we're gonna stick with Pinecone, and I've already pre-created the connection. I've entered my API key to Pinecone, and here I'll do something like HR knowledge, and hit create. So what it's going to do, it's going to create a knowledge base entity that is also accessible by the REST API endpoint. So we can start ingesting files either programmatically through this API endpoint. Just need to obtain the access key that you can find out here. That's when you have like lots of files. We can also connect, as I said, Google Drive. So I already added my connection, and can say, it's HR policy, select my Google Drive connection and select this this thing and select the HR policies folder. So now I hit create, and it's going to start loading all the documents in this folder. So it's only one, which is already being loaded. As well, I can actually upload documents from my laptop as well. So I added another document, and now it's being processed. So what's happening? Each document will go through this workflow. So first we'll do the pre-processing, convert these PDFs that I just uploaded to a markdown format. Then we'll do the split into chunks. Then we'll convert these chunks into vector representation using OpenAI embeddings, and then store them into our vector DB, which is Pinecone. So that's gonna take a couple of minutes. This file is already processed. We can actually see the trace, so see what happens, how this file was pre-processed using, in this case, unstructured file converter, how it was split into which chunks, what was the input and what was the output. In this case, it's only 2 chunks. And then we can even see how these chunks were embedded into the embedding models. We can see that it worked fine. And then these documents were stored in the vector DB. So you can play around, change something if needed. So now that we have this knowledge base, we can also probably go to our Pinecone and just check it one more time there. Make sure that it's actually loaded. Chart knowledge. So yeah, we can see for now 2 chunks already there. Okay, cool. So now we can head to our workflows and start with templates. So when we hit create, we can see some of the templates that we've already pre-created. And in this case, I can probably start with like query refinement RAG. So in this case, we do an extra step before the embedding of the query. So we actually added another LLM call and asked the LLM to actually rewrite the query in a way that's more suitable for the vector embedding. So you can extend this instructions to strip out the irrelevant words that might be meaningless for the semantic search and things like that. So the main point here is to change the query in a way that it's capturing more relevant contextual information when it's converted to the vector embedding. You can also do more advanced techniques like hide, which we can talk in the other sessions using this approach. But in this case, we've taken this approach. We converted to, again, the OpenAI embedding model, and then we retrieve documents. The only thing we need to change here is the index name. In our case, it's HR knowledge. You can add some filters if you want on top. And in this case, we also applied some re-ranking, which is time-weighted re-ranking mechanism. And at the end, we have this node that generates the final answer. So it takes as an input the prompt and also adds the context with the relevant documents that we've retrieved. So in this prompt template, we support a Jinja 2 syntaxes, so you can iterate through documents and add queries. So that's how it works. We can probably, okay, I need to add the connection here, which is my Pinecone token, and we can hit test and ask some questions. Ready? See. And hit run. So it's going to take a while because we are going through several steps here, but yeah, basically we'll see the execution graph, like what happened, how our query refinement step worked, how the text embedding node worked, what chunks did we retrieve in this case, and how the re-ranking worked. So basically, how did it manage to change the positioning of these documents, and then the final answer, which tells us that we're entitled for like 10 working days of vacation. So what I can do now is save it. So HR chatbot, save this workflow, and now I can also deploy it. So we can start chatting with it through API or through some UI components. So I'll hit deploy. And what we'll get right now is this RAG application is going to be available as the API endpoint. So you can start integrating it into your front end or back end. Again, you'll need to obtain the access key to access these things. You can also test it again from here. Application policies. Let's run it and make sure that after deployment it actually worked properly, which it should. Takes a bit of time for the first request, but yeah, we've got the answer. And we can also see the trace for this request, how long it took. And again, the same steps, you can see exactly which step took how much, even the cost and other things. So when we go under the observability monitoring tab, you will see how many tokens did we consume, what was the cost, what was the latency, and other things. And then we can also now go under chat and chat with this chatbot in more like ChatGPT style. Again, it's I think I need to disable streaming because I didn't enable it in the UI. Oops, actually I need to check. Probably, yeah, we haven't enabled streaming. So if I enable streaming for this node, so it means that this node will be streaming its output, and we can save it again under version 2 and actually go ahead and redeploy. So we can say, okay, now I have version 1 deployed, I want to deploy version 2, which is done now. So version 2 is deployed, and I think it should work. We enable streaming and go ahead. Yeah, so it works. We just need to make sure that the node that will be producing the last answer should have enabled streaming in it. So yeah, this is how you can test it. And again, we will be able to see all these requests out here as well. So now we can do something a bit more advanced, as I said. So we can probably start with an agentic RAG. So try to drop our agent node, connect the input with the agent's input and the agent's output with the final output of the workflow. And what we'll do here is we can select the LLM that is going to be acting as the brain of this agent. We can start with Anthropic. Let's use Claude 3.5, 3.7. And as one of the tools that we allow this agent to use, we can use knowledge-based retriever. So here we'll select this HR knowledge base that we've created, and that's pretty much it. So this agent now will be able to actually use this knowledge base that we've created, and we can say here you are helpful HR assistant. Obviously, probably in the real world, you want to make it a bit more advanced, but just for the sake of the demo, we can make it quite easy. And then try again with the vacation policies real quick and see how this agent will behave. Might take some time because here we're using React agent that does the reasoning and acting. So it might require a couple of steps to arrive at the final answer. But yeah, we can see what happened here. We can see that there was the thinking step, decided to query the vector DB using this query, like vacation policies, performed the embedding step, performed the retrieval step, retrieved some documents here, and then did the final output generation, which basically provided similar results to our initial workflow. So we can also save this and say this is agentic RAG. And that's pretty much it. So in this case, as you see, you don't need to do all the step-by-step stuff. Like the agent itself is in charge of query rewriting, embedding the documents according to the text embedder model that we've selected, and the retrieval part from the vector DB. We can always extend the functionality of the platform by just embedding pure Python code. So the platform is low code. So if you want to actually extend beyond the building blocks that we have, you can drop a Python node and then code an extension on your own. So it doesn't stop there. It doesn't stop only with the building blocks, but there's quite a lot. So we have the ability to specify like if else logic using the choice node block, map through arrays using this for loop node. You have all sorts of single agents, multi-agent orchestration, the tools for searching, scraping, ability to query external databases, external HTTP endpoints, all sorts of LLM providers, pretty much everything that is available on the market today. In addition to voice to text, text to voice, a variety of guardrails and validators and detectors like PII detector or prompt injection detectors, as well as the ability to pre-process different types of unstructured files, all sorts of chunking, and re-ranking mechanisms, vectorizers, and vector store integrations. So it's pretty robust. Okay, I see there's one question. Whether we can customize the workflow and decide whether to go with RAG or just LLM call. Essentially, yes. I mean, the platform is pretty flexible, so you can potentially, as I said, have a choice node. Maybe in order to define the route, you might have something like OpenAI call that is prompted to say something detect if I need to search internal database to answer this question. Okay. Yes. No, something like this. Quite simple, but I think it gives you the point. So this node will like make decision, and then we pass these to a choice node. Here we might have different rules. So if rag, then specify some make decision output is equal to yes, and then basically perform rag. So just for simplicity, let's say this is just the simple LLM query, and then for RAG purposes, we can have another flow that embeds the query and then searches the data in the vector database. So yeah, that's how it can work. So in this case, this workflow will look something like this, where we have two different outputs from two different subflows. So that's how it can look like. Again, you can plug in Python code anywhere here in between of these steps. Same goes for, I hope this answers the question, but like same goes for the knowledge-based pre-processing as well. So we have the capability to actually edit this workflow. We provide a blueprint that covers probably 80% of the needs of customers, but you can always jump into the editor of the RAG ingestion workflow and essentially define any step here on your own. So if you would like to replace the document splitter, let's say with something more custom, then you can always plug in the pure Python node and then code that split strategy on your own. So nothing stops you from like customizing this ingestion pipeline. Okay, there's another question. I want to optimize for speed, low latency. Yeah, so how to optimize the speed and the latency of your RAG pipelines. I guess as the deployment platform, we're trying to add as low overhead as we can, but I guess if you go under the deployment and observe the traces, it already gives you some hints on which steps run for how long. So you can see that, for example, this LLM step that does the query refinement is pretty fast, more or less. The embedding model, again, is pretty fast. The retrieval is even faster. The re-ranking is almost nothing. And then the majority of the time is spent in generating the final answer because it has quite a big context. So the input tokens are quite big because we've embedded a lot of documents. So by kind of observing these traces and logs, this is something that you can use to actually optimize it. So select the faster LLM, select the faster vector store, add or remove re-ranking if it causes the thing, which is not in the case right here, but maybe remove the like refinement step if you feel this is too slow. But yeah, there's plenty of ways these RAG pipelines can be optimized. I guess another thing is enable streaming of final results, so it feels for user much faster, so they don't wait like 3 seconds at all. They keep seeing results as they come through. But what can be done as well is enable intermediate steps streaming as well. So you can show user an indication something is happening, like the search retrieval part is running, and other things are running, so they don't feel it's stuck. But yeah, in general, if you have more specific questions, we can discuss it on the call. We'll jump back to the presentation. Also wanted to share some of the resources that might be helpful for you to go through additional RAG examples. So as I mentioned, we have the open source package that you can check out on GitHub. It contains a lot of RAG related and agentic examples under the examples folder, which you can check out. We also have quite a few blog articles related to RAG as well. If you want to play around with the platform for free, just go to app.getdynamiq.ai and sign up. Doesn't require any credit card, so it's pretty easy to reproduce whatever I was showing today. We also provide like free tokens for majority of the LLM providers, so you don't need to spend any money on that. When you feel stuck, there's the documentation of the platform, which is pretty extensive. And then if you have any questions and anything to ask for, hit me up on LinkedIn. I'm pretty responsive, and don't hesitate to schedule a demo of the platform or a deep dive call. But yeah, that's pretty much everything I wanted to cover today. If anyone has any more questions, I'm happy to answer. So yeah, well, let me know. Let's stay for a few minutes, and I'll try to answer the incoming questions. Okay, so there's another question around MCP support. Yeah, this is something that we're working on. Should be released in the next couple of weeks. We're trying to do the best effort possible, so not very rushing with the MCP. There were a couple of changes that Anthropic have done to the MCP protocol, so we're actually monitoring all of these, and we'll be adding MCP ASAP. But even with this beyond MCP within the platform, we already have the capabilities to actually when you define agents, to define custom tools. So I'll just quickly show it here. When you define the React agent, when you select tools, you can already define your own tools using Python. So I can define something like get user info, and then import requests, and then just code this tool on my own. And then you can do the same with like HTTP requests. So I can actually define an endpoint, define the way to authenticate, some parameters to send, and convert this HTTP call to a tool. So it can be something like move money or things like that. So it's already possible, but yeah, we'll drop the MCP support quite soon. Cool. Any other questions from anyone? Okay, I guess there's one more question around like which vector databases are recommended to be used in production setting. So this is a tricky one because majority of the vector databases that I mentioned today, like Viviet, Quadrant, Pinecone, they're quite ready to be used in production. It just depends on your preference. Vector DBs like Viviet and Quadrant are great, scalable, open source solutions that you can even host on your own. Pinecone is a great scalable solution that runs on the cloud, but it's proprietary. Chroma, I would say, is a bit more useful when you're running something locally and want to test things quickly, but I wouldn't recommend it in production as of now. But then there's a lot of use cases where people use, let's say, PG Vector or Elasticsearch, because these are the systems that they've already been running. I wouldn't say that PG Vector probably is the best choice, but it's good enough for a majority of use cases if you already have Postgres as the database. Okay, there's another question around agentic memory. Yes, so we do support memory. I'll jump back into the platform. You can enable memory for the agent, and you will need to select the vector DB that powers it. You will be storing the memories in this vector DB, and that's kind of how that works. So in this case, I can select, let's say, Pinecone and select the retrieval strategy for the memory, and I'll be storing these conversations in this specific database. So again, we can select the embedder to use, and once I've enabled this, the agent will start to have like additional parameters that I can pass, like session ID, user ID, that will be used to distinguish which memories to retrieve for which user. Cool. There's another one. Ingestion pipeline. Any suggestions for resources to have the best chunking strategy? It actually depends really on the documents that you're working with. I guess the easiest thing is to test it on your own, right? So if we go into this workflow, we can also drop some documents and see, how the chunking works, and if it chunks documents into meaningful pieces, right? So in this case, one of the first things to do is to see if the output of this node is actually meaningful, if it means something, if it's good enough. But as an extra step, like beyond that, when you define the workflow, what you can do is you can use our evaluation metrics module that I can go through probably in the next session. But we allow you to define metrics either using LLM as a judge, or some predefined metrics specifically for RAG, like context precision, answer correctness, and other things, or define metrics in pure Python that you can use to actually evaluate your workflows. So what you'll have is the side-by-side comparison of each workflow that will help you decide, let's say, does the chunking strategy works better in this workflow or this workflow? But yeah, that's kind of probably a topic for another hour. So if you add the Google Drive, you don't need to do much. So as I showed before, when you define the connection with the Google Drive, it actually runs automatically and syncs all the files. So right now we just automatically sync files every 5 minutes. So if something is changed, if documents are added, new documents are added, existing documents are changed, some documents have been deleted, like we'll pick it up and we will detect this and rerun the ingestion for these files. So you don't need to actually worry. Same for other integrations with like Dropbox or Microsoft One. it's going to be the same. So you don't need to worry. Like when files change, you don't need to rerun anything. Hope that that answers your question. Can we use NVIDIA related LLMs? We're working actually on adding NVIDIA NIM integration, so should be ready next week. So you can use models directly from NVIDIA NIM portal through the API, or even those models that are self-hosted through NVIDIA AI Enterprise. But yeah, that's coming next week. We're in the process of adding that. Waiting for a few more questions and we can probably wrap it up. Okay, seems like we're good to go. Thanks everyone for attending today's webinar. If you have any more questions, feel free to sign up. Feel free to book a demo through the platform. We have the functionality to kind of reach out to us. Always happy to chat with more folks and help you with your GenAI use cases. There's also a support email. So if you get stuck, email us at support@getdynamiq.ai. But yeah, there's also documentation that is quite extensive. So don't hesitate to register and reach out to us. And we'll keep you posted about the next webinars, which probably will happen quite soon. And we can cover more advanced agentic use cases and also talk more about the evaluation strategies for your RAG applications and agents as well. Thanks, everyone. One more time, just gonna drop the final slide. So if you also want to connect directly, feel free to reach out to me and we'll speak soon. Have a great day. Bye-bye.